Welcome back everyone. Today we're going to learn about a very simple tool, a tool that originated in manufacturing and is now widely used across a range of industries. The tool in question, spaghetti diagrams. Spaghetti diagrams or spaghetti graphs are simple yet powerful tools used to study and visualise the movement and transportation of people or products. At this point in the course, we're all very aware of the need to minimise waste. A spaghetti diagram helps visualise and quantify the waste of transport, allowing focused steps to then be taken to minimise these mooders. Spaghetti diagrams also help to identify optimised layouts and visualise the flow of people and products within our system. A spaghetti diagram helps us understand what happens at the gemba, how the products flow, and where the operators move. It is important to note here that, just like value stream mapping, spaghetti diagrams themselves are not improvement tools. They are meta tools that help uncover the current state and allow improvements to be identified. The same way a doctor first carries out a diagnosis of a patient using tools like X-rays or MRI scans before deciding on how to proceed. Just like these tools, completing them on their own won't make improvements. But when followed up with other tools, like 5S or a Kaizen event, focused on layout optimization, they can be incredibly powerful. So what is a spaghetti diagram? Well, it's a visual representation of the physical movement of people or products through each of the tasks or activities carried out in the process. When used with people, it traces walking patterns, distances, and times between tasks. When used for products, it details the flow, distance, and waiting time of the transportation of the item. Traditionally, a spaghetti diagram is completed with a printed floor plan of the work environment, and the movement of the person or product in question is traced onto the sheet of paper with a coloured pen, following the person with a pen being drawn in a continuous line. The result is a chaotic-looking visualization showing where they have travelled, which resembles spaghetti, hence its name. Although messy, the diagram paints a good picture of firstly, how much the operator has moved, and secondly, identifying the locations they have moved between. So how practically do you complete a spaghetti diagram? Well, there are 5 different steps in creating one. The top banner of the spaghetti diagram includes the data recording information. The second part is the person and product flow diagram. The third element is the investigation into why long or frequent movements occur. And finally, the distance travelled and value add percentage is completed. Step 1 is filling in the process information. This includes the name of the person conducting the observation, the date, time, and name of the process being observed. Although obvious, these elements are an extremely important part of the spaghetti diagram as a whole, because being able to trace back the data to the process when discussing improvements is critical to avoid miscommunication. The observation time should be recorded once the observation has been completed. In terms of how long to observe, I would suggest watching at least one cycle of the workstation as a minimum wherever possible. However, this may vary depending on the nature and duration of each cycle. Typically, 30 minutes observation time is long enough to paint the picture required for each workstation or process. The second step is the person and product flow diagram. This is the part that people think of when discussing spaghetti diagrams. This part of the spaghetti diagram visually maps the flow of people and products around the work environment. The first thing to do here is define, with the assistance of the operator, where the boundary of their work area is. This should be a localized area where they conduct their value-added work. Typically, it will be a workbench, a cell, or a workstation. It is important to clearly identify the work area onto the aerial floor plan, as it will be used throughout the analysis. Make sure for this part that the work area is only the area where the operator adds value. Any work area that are used for storage, transport or rework, etc. should not be part of the work area. When you are ready to start your observation, start the stopwatch and follow the operator with your pen and paper. Every time the operator moves away from their defined work area, press the split function on the stopwatch and record the time until they return. Once they return, label the movement on the spaghetti diagram with a number and write down the duration of time they spent away in section 3 under the appropriate area. This we explain more in the next step. This step is all about understanding where the operator moves. When they leave their work area, where do they go and for how long? The next section of the spaghetti diagram is where you become the detective. The idea is to investigate each occasion when the operator leaves their workstation to understand why. In order to prevent disrupting the operator, simply record the split times from your stopwatch for how long they are away each time and write the number onto the spaghetti diagram in a different colour so you can match the time with the specific movement. Once the observation has been completed, you can then ask the operator what they were doing in each of these occasions, noting down the specific tools they were collecting, the reason they were moving away, or any other important information that may be useful later. The fourth part of the spaghetti diagram is where you record the total distance travelled throughout the observation. This information, in combination with part 5 of the spaghetti diagram, will provide data that will help prioritise improvement efforts after the analysis has been completed. There are two methods for recording this data. The first way is to calculate a rough estimate of each operator's distance walked. This is easier done on a to-scale floor plan, which is why I mentioned this earlier. In this case, it was estimated that the operator walked 28 metres in 14 minutes, which equates to roughly 2 metres travel per minute, and that's very low. The second method for calculating the distance travelled is to use pedometers or step counters. By using a pedometer, you can easily and relatively accurately measure the total distance walked by simply multiplying the number of steps by the average size of a step. Also, pedometers are very cheap and simple to use. You can easily measure the step count of a large number of employees without the need for much manual work. This provides an overview of transport waste on a macro level and is particularly useful to carry out before going into detail of the spaghetti diagram. Conducting spaghetti diagrams only on the operators that have walked the furthest with the greatest opportunity for improvement. For example, if you handed out pedometers before you started the spaghetti diagram, you would be able to see that process 5, process 6, process 8 and process 10 do the most steps. It would therefore be worth doing spaghetti diagrams in detail on those specific processes only. The operator at process 3, for instance, does such a small amount of steps in a day that it's not worth conducting the spaghetti diagram on that individual process. The final section of the spaghetti diagram, and the part that works closely with step 4, distance travelled, is the value add percentage, calculated by dividing the time the operator spent in their work area by the total observation time. In other words, what percentage of the observation time was the operator within their defined work area. We can assume that any time spent away from the work area is not value adding. The final value add percentage number gives a great indication, along with the distance walked, for what operation should be the primary focus for an improvement tool. As mentioned before, this spaghetti diagram itself is used as a meta tool, identifying what and where an improvement tool should be used. Remember, it is always best to first take a holistic view, produce a graph and prioritise your efforts to select the biggest opportunities for improvement. With that in mind, if we found that this particular process had the lowest value add percentage out of all of our observations at only 15% value add, we could then break down the investigation section to identify where the largest savings could be made. In this case, it would suggest optimizing the tool collection process and the work in the prep area, signifying that 5S could be an effective improvement tool to be used for this occasion. To quickly summarize the 5 different steps of the spaghetti diagram, you first need to gather and complete the process data. You should then speak with the operator and let them know the purpose of the spaghetti diagram and define the work area with them. If you are going to use step counters for the distance travelled section, then now is a good time to give it to the operator and start the observation. Commencing the person or product flow diagram, every time the operator leaves the work area, use the split function on the stopwatch to record how long they are away for, writing the time and brief description of what they were doing in the investigation section and labelling the motion line. Next, you can either measure the distance travelled manually by estimating it from the flow diagram or using step counters. And finally, the value add time should be calculated by using the total time within the work area divided by the total observation time. So let's put this example together and view it as one completed spaghetti diagram. For this example, we'll be looking at an automotive part supplier producing an engine. The observer is James Harari, the date is the 10th of September 2020 at 11:30, and we're observing the engine assembly for the engine short block. Observation duration 14 minutes. Now that we've filled in the process data, we can start the actual observation. Please follow along with the video, the person product flow diagram, and the investigation section being completed simultaneously. For this example, we are following the person on the left-hand side of the video. He's now collecting the tooling. Now he is waiting. He's now in the prep area. While the operator is in the preparation area, if you haven't had a chance already, please look at the investigation section and the product and person flow diagram to see how they've been populated. Now he's back and he's moving parts. He starts searching for screws. And now he starts the actual screwing operation. Finally, he finishes and moves back to the start. And that is the observation complete. As you've seen with this example, this is how you calculate the distance travelled. Once that has been completed, it's time to finish by calculating the value add percentage. When recording the value adding time, precision isn't the main aim here. There will be micro wastes involved with everything. Practically, this is extremely hard to measure, so if the operator is fastening a bolt for 60 seconds, spends 5 seconds scratching their head, and then continues to spend 55 seconds fastening the bolt, it is not a problem to categorise it as 120 seconds value add, not 115 seconds. The reason I say this is because the spaghetti diagram is partially a prioritization tool, so you know where to focus your efforts. The difference between 15% value add or 17% value add isn't significant. And there you have it, that's a completed spaghetti diagram, showing exactly what was observed, an understanding of the operator movements and durations, as well as the value add percentage and distance travelled. Now you have a much better idea of how the process could be improved and the type of lean tools that could have the most significant impact. Now that we have covered spaghetti diagrams and ran through an example, I'll now discuss some tips and things to watch out for when practically applying this tool. Firstly, spaghetti diagrams are not intended to be highly accurate, precise tools. They help visualise the wastes of motion and transport and identify the occasions where operators are spending a lot of time away from their work areas. Spaghetti diagrams help put the going to Gemba mentality into practice, and often open your eyes to other improvement potential that could be missed. Spaghetti diagrams enable you to ask questions that help uncover opportunities for improvement, questions that will help make a positive change for that operator, and this is an important thing to note. Some operators may think they're being blamed or at fault for a large level of transport or motion and time away from their work area. This is not the case. Remember, these wastes are golden opportunities for improvement. It is therefore important to put the operator at ease before you start observing and explain the output of this exercise. Toyota puts huge emphasis on this going to Gemba and observing mentality, and upon joining the manufacturing business, for the first month, graduates typically spend 90% of their workday at the shop floor, creating spaghetti diagrams and understanding the processes. Having completed your spaghetti diagram and found a process with scope for improvement, the next step involves carefully selecting which improvement tool to use. Different tools have specific uses, so selecting the right one is very important, and sometimes a combination of tools provides the best results. Unfortunately, there are no hard or fast rules to follow in order to select which tool to use. However, by using logic along with some guidelines, it soon becomes visible which tool to select. If there are large differences between operators when observing the same process multiple times, then standards should be selected primarily as the improvement tool. If you find there are frequent long-distance movements back and forth to different workbenches or work areas, then layout optimization would likely be the best improvement tool. If the investigation section of the spaghetti diagram shows a large portion of the time spent searching for and collecting tools or equipment, then 5S is likely to be the best improvement tool. Finally, perhaps you find there are lots of small movements around the product to collect parts and tools, in which case something called border of line and kitting improvements may be most useful, making sure that all the parts are as close to the product as possible. There may also be some very intuitive or innovative solutions that don't require the use of an improvement tool. For example, if the operator travels a significant distance to look up the work order details, then perhaps that task could be completed automatically using an electronic handheld system or iPad. Or perhaps the work order slip could be attached to the product as it moves along. Additionally, certain processes could be simplified, combined, or even eliminated. Sometimes, by being at the Gemba and making the observations, other things may be found. Are there defects being caused, errors, searching, waiting? All of this can be tackled in a problem-solving workshop. Because spaghetti diagrams have to be done at the Gemba, they are often very eye-opening and signify other problems that would be missed otherwise. Finally, once you have made the improvements, you need to redo the total distance walked and spaghetti diagram to see the effect of your improvements. Remember, when looking at a spaghetti diagram, simplicity is good. The simpler and smaller the movements, and the more compact the spaghetti diagram looks, the less motion and waste you are likely incurring. This is the part where you check that you are getting the desired results. Perhaps you have missed something or can make further improvements that were missed originally. Let's look at a simple example. In this example, the chef in a pizza restaurant has to move frequently back and forth between work areas. The solution would point towards layout optimization. By moving some of the equipment around into a U-shaped cell, the chef now works in a highly efficient work area with greatly reduced transport waste. Also, the sign of a well-designed work environment is where other operators could be added without causing disruption. An additional operator could easily be added during busy periods to isolate the transport waste to that one operator. Although it's not the purpose of this module, I thought I'd mention the recent advancements in technology that have made this whole process much faster. It's now possible to get relatively low-cost trackers, which are able to locate products or people within 2 centimeters accuracy. Placing a tracker on a person will give you similar information to a spaghetti diagram, but with a much higher accuracy. Exact timings and exact distances for each task can be deducted and overlaid onto a floor plan. The 3 benefits of using motion trackers include increased data collection, higher accuracy of the data, and higher resource efficiency, as you don't need as much manual work. The negatives are of course the cost and complexity of carrying out such an analysis. For many companies, this could be seen as overkill, with the traditional approach being much simpler and capable of spotting improvements. In my opinion, there are many merits to using the traditional approach, including encouraging people involvement. So let's summarise what we've learned in this module. We've learned that spaghetti diagrams are meta tools. They should be used before selecting an improvement tool, whether that be 5S or standards. We've learnt that spaghetti diagrams help identify one of the 7 mudas, wastes, the waste of transport. We've learnt that spaghetti diagrams follow a 5-step process and put into practice the important principle of going to Gemba. Sometimes going to Gemba, you make observations and see other wastes that otherwise you would miss. Finally, we've learnt that low-cost solutions like step counters or pedometers can really help in terms of prioritising where to do the spaghetti diagrams to get the greatest impact. Please join us on the next module where we'll learn about value stream mapping, a very powerful meta tool that instead of focusing on one of the 7 wastes, focuses on the whole system, on Muda, Mura and Muri.